Hi, myself Dr. V. A. Kamble. I am from Department of Mechanical Engineering, Institute DKT's Textile and Engineering Institute Ichalkaranji. Hi, myself Dr. V. A. Kamble. I am from Mechanical Department, DKT's Textile and Engineering Institute Ichalkaranji. Today we will discuss automatic control. What is automatic control? Introduction to course. Welcome to the first lecture on automatic control. This subject is fundamental to many engineering fields, including aerospace engineering, automotive engineering, manufacturing, robotics. Meaning of automatic. Automatic means achieving and maintaining desired output performance from a system regardless of varying inputs or external disturbances. Why do we need control systems? The role of the control system. System interact with their environment, but disturbances from environment can affect system's performance. Good morning, everybody. I welcome you to the lecture of the subject automatic control. Today we will see lecture 1, definition and types. Control systems, automatic control, open loop, closed loop, and these lectures are delivered by Professor Anil Kumar from IIT Roorkee. So why this automatic control is important? So it is widely used in aerospace, automobiles, manufacturing, robotics and electronics. Lecture overview. You will learn in this lecture what is system, what is control system, the elevator a real example, open loop control system, closed loop feedback system, open loop versus closed loop. We will start with what is a system. Definition. A system is a collection of components which are coordinated together to perform a function. So if we consider the main part of the automobile vehicle, so it will include IC engine, then transmission system, related controls for driving the vehicle like steering wheel, brake, clutch and accelerator. So this complete collection of components will be known as a control system. So we will see now some terms. Boundary. Why system? Because it is a region separated from its surrounding or environment. This separation is called boundary. Everything outside the surrounding is known as a environment. Always there will be the interaction between system and surrounding. So input signals we feed into the system, output will be generated by the system. It will be the response to the input. Also there may be the disturbances or unwanted inputs from environment. Example, outside noise while listening to music. Subsystems. Inside the system there are multiple components called subsystems. Each subsystem takes an input and produces an output. Together may perform the overall function. So here system diagram is shown. So some input signals will be provided to system and system will generate some output. What is a control system? A control system consists of subsystems and processes assembled for the purpose of obtaining a desired output with desired performance given a specific input. What is a specific input? The input is in our control. We deliberately command the system. Example, pressing button 4 in an elevator. We know what input we are giving and what output we expect. So when we press 4 in the elevator, that lift will start moving and it will reach to the 4th floor. Desired output. We do not want just any output, we want specific expected output. So in case of elevator, that should stop exactly at 4th floor, not 3rd or 5th floor. Desired performance. Significance of output. The degree of accuracy and how well it satisfies the user. Example, how quickly does the elevator reach floor 4? Does it stop level with the floor? Why do we need control? Because disturbances from the environment enter the system and push the actual output away from the desired output. Without a control system, we cannot guarantee the system perform as expected. The elevator, a real world example. So here we will see transient response and steady state error. Specific input. In case of elevator, we press 4 from ground floor. So command equal to go to the 4th floor. Transient response. The initial time varying motion. Elevator accelerating and decelerating. So this part is changing with time. So this response is known as a transient response. Steady state response. The final constant value. Elevator has stopped. This is what output settles to permanently. Steady state error. Difference between floor 4 desired and the actual stopping position. If the lift stops lower, passengers must jump out. So it will be unsafe. So that difference is known as a steady state error. Performance trade-offs. If transient is too fast, so it will be discomfortable for passengers. If it is too slow, if that lift is too slow, longer waiting time will be there. So poor performance test. Oscillating, dangerous, very uncomfortable. Steady state error greater than 0. So floor not level, unsafe, jump needed. Control system design goal, transient, comfortable and fast. Steady state error as small as possible. So there are two types of control systems, open loop control system and closed loop control system. So input is given to input transducer. That transducer will convert that signal into usable form. Then controller will take some action. Also there will be the effect of disturbances to that controller. Then next part is process plant. Also there will be the presence of disturbance, and that process plant will generate output. So here in case of open loop control system, there will not be feedback path. Output is never monitored or compared back to the input. Characteristics of open loop control system: cannot compensate for disturbance 1 or disturbance 2. Output may be different from desired output. Simply executes input command blindly. No mechanism to counter environmental disturbances. So examples of open loop control system: toaster. So there will be the set time. It does not check if bread is burned or perfectly done. Second example, washing machine. Runs preset cycle but does not sense actual cleanliness of cloth. Electric fan. You press button 4 but it does not verify actual speed. Another type is closed loop or feedback control system. It monitors output, detects error, and corrects automatically. They monitor output and compare it to the input. If there is error that is detected, the system connects the output and hence corrects the effects of disturbances. So here that diagram is shown. Input will be supplied to input transducer. It will supply usable form of signal to controller. Control action will be taken and process plant will be run, and we will have output as per design. So disturbances will be to the controller as well as to process plant. The error signal drives the controller. The loop runs until there is a zero error from desired output achieved. Advantages: greater accuracy, steady state error will be very small. There will be less sensation to noise, disturbances, temperature changes. It monitors continuously, so self-correcting mechanism will be there. Examples: air conditioner. So it measures room temperature compared to the set temperature and adjusts compressor speed. Complex smart toaster reads color of the food, not just the time, and adjusts it accordingly. Disadvantage: more complex, expensive. Automatic control system must be closed loop. Here we will see the difference between open loop versus closed loop. Monitor output. In open loop, it never checks the output. In closed loop, continuously monitor the output. Feedback path. There will not be feedback path in open loop. In case of closed loop, it present. So output feedback to input. So compensation of disturbances. In case of open loop, No disturbances corrupt output. In closed loop, yes, it detects and corrects the errors. Accuracy. In case of open loop, it will be poor. Output differs from desired. Closed loop. Greater accuracy will be there. Low steady state error will be there. In case of open loop, it will be very sensitive to disturbances. Closed loop is less sensitive, self-correcting. Open loop. It's simple forward loop only. In closed loop, complexity will be more, need sensor plus feedback loop. Open loop system is less expensive. Closed loop is more complex and expensive. Examples of open loop system: toaster, washing machine, fan. Examples of closed loop system: air conditioner, smart toaster, microwave. So why automatic control is important? In aerospace, autopilot system, altitude and thrust control will be there. Supercraft orientation and all need feedback control. In automobiles, ABS braking, cruise control, engine management, electric vehicle motor control will be there. In manufacturing, CNC machining, robotic welding, chemical process control, precision assembly will have applications. In robotics, precise joint position control, walking balance, surgical, robot accuracy. HVAC system, temperature regulation in buildings, the air conditioner, example from this lecture, power systems, grid frequency control, voltage regulation, renewable energy integration. Automatic control ensures reliable, safe, efficient performance in all engineering systems despite real world. Lecture summary: a system, a collection of coordinated components separated from environment by a boundary, input center, output leave, and disturbances corrupt from the environment. A control system is designed to achieve desired output with desired performance, transient plus steady state for specific input despite environmental disturbances. Open loop systems simply execute commands. They do not monitor output and cannot compensate for disturbances. Simple but inaccurate examples are toaster, fan, washing machine. Closed loop systems take output feedback, compute error, input minus output, and keep correcting until error is equal to 0. Accurate and disturbances resistant. Examples are AC, smart toaster. Automatic control systems must use closed loop feedback design. Open loop cannot be automatic control system. Thank you. So books referred are Control System Engineering by Norman S. Modern Control Engineering by Katsuko Ogata. Thank you.